Welcome, everybody. Today's webinar, Future Ready IT, How Containerization Powers Modernization and Agility. We're going to talk today briefly about containerization and give you guys an overview before moving into single versus multiple containers. Then Tom will do some work on assessing your environment and discuss how best practices for that before we move into some tips on modernization. And then we'll finish off talking about some next steps on your journey. My name is Shean McManus. I'm field CTO here for our modern apps and data team with Netrix. I'm joined today by my colleague, Tom Lilly, who is our field CTO for the cloud team. And we're excited to talk with you and speak about containerization.
Absolutely.
So before we dive into containers, and you can go with one more slide there, Tom, be great. Let's take a step back and understand how we got here, because the challenges that containers solved didn't appear overnight. For decades, the standard approach was bare metal, on-prem data centers, server racks, networking, all of that infrastructure. You need a new application, you bought a new server. That meant massive capital expenditures, months of procurement lead time, and the reality that most of your servers were running at maybe 10, 15% utilization. It was incredibly wasteful, but it was really the only option. Then virtualization came on, and that was genuinely transformative, where VMware, Hyper-V, other hypervisors would let you be able to carve one physical server into multiple virtual machines. And suddenly you could improve density, reduce hardware costs, and your provisioning would drop from months to days. But virtualization didn't solve everything. Each VM still carries a full copy of that operating system, which creates additional unnecessary overhead for your workloads. This would lead to like another management problem, VM sprawl. So organizations would end up with hundreds or even thousands of VMs that were tough to track, tough to keep updated with patching, and difficult to right size as well. On the developer side, these challenges has persisted with a VM-centric infrastructure. So things like environment drift between your development and your production environments. You'd be making ad hoc changes to one or more of those that would accumulate with different libraries, different dependencies, configuration files, and patching. And these accumulated differences between those environments would lead to an inconsistent user experience for all of your users. And additionally, these challenges would persist to optimization and scaling as well. So virtual machines mechanisms exist to address scaling, but they're imperfect and they're challenging if you need to respond in real time to unexpected demand spikes. So as a result of all these gaps, cost controls with VMs, while much better than traditional standalone hardware, it was still an imperfect and suboptimal exercise. And these were like the exact problems that containers were built to solve. So given that context, let's look at what containers actually are and why they're such a fundamental shift. So first of all, at its core, a container is just a lightweight package that includes everything that an application needs to run. So application code, runtime, the libraries, and system settings. But critically, most importantly, does not include the operating system. So that's what makes these containers lightweight. Unlike a VM, containers share the host operating system's kernel. So instead of gigabytes per workload, you're talking megabytes, which reduces that startup time to just seconds. Additionally, that lightweight nature enables portability. So when we say like build once, run anywhere, that's what we mean. You're packaging that application and its dependencies all together, wrapped together, and they behave the same on the developer's laptop as they do in test or in your production environment. And finally, isolation. Each container runs in its own isolated process space. So that way applications aren't colliding with each other, even though they're sharing that same underlying infrastructure. So this level of isolation is what allows teams to deploy faster without having to worry about breaking neighboring workloads. So it's a big mental shift here. Containers aren't miniature virtual machines. They're essentially isolated processes that are optimized for speed, consistency, and scale. So that eliminates, once we understand what containers are, the next question is why have enterprises adopted them so aggressively and how they solve the issues that we've discussed with legacy systems. So that first driver is speed. Containers start in seconds, so that dramatically accelerates how your teams can build, test, and deploy applications. You're no longer waiting minutes for infrastructure to spin up just to find out if a change works. That speed feeds directly into your whole development operations life cycle. So from that perspective, containers give your development and ops teams that shared consistent unit of deployment. So the container image that a developer builds in locally is that exact same artifact that flows through the entire CI/CD pipeline and ends up running in production. So that eliminates an entire class of problems, like no more, oh, this worked in test, but it failed in production because the environment was slightly different. No more custom deployment scripts for each server. You're promoting like that same immutable artifact through each of those stages. It also enables automation. So if you're building an image and you're being able to run tests and scanning for vulnerabilities while you're deploying, all of that can happen automatically. Like, so no more like manual change windows and handoffs. That can largely go away. Efficiency is another big reason to leverage containers because they share that host operating system, as I mentioned on the previous slide. You can run more workloads with the same infrastructure compared to VMs. And that higher density translates directly into better resource utilization and lower costs. And now let's talk about scalability. Like that's really where containers shine in production. So like imagine a retail or ticketing application during a seasonal spike. So say Black Friday or a registration opening day or like some major marketing campaign. You might get your traffic jumping 5x or even 10x in a very short window. In a traditional VM model, you're either over provisioned all year or just in case you're scrambling to add servers when that spike hits. With containers and orchestration, that scaling can be far more granular. Instead of scaling entire virtual machines, the platform can spin up additional instances for just a stress service like your checkout or your search. And then when that spike passes, those containers can scale back down automatically. So you're no longer paying for idle capacity and you're no longer having to rely on humans to react under pressure. Like that's essentially that shift. Scaling stops being that responsive emergency sort of exercise and becomes a more built-in behavior of the platform. So when you put all this together, you can see why containers have become such a big deal for modern platforms. It's not just about modernizing your apps. Containers genuinely change that game and how in terms of how fast your teams can respond and how much more you can get out of your infrastructure.
Yeah, and one thing I just want to jump in before we go to the next slide here. Yep. That last comment about scalability, we're seeing a lot of our customers really take advantage of that as they move into the cloud, because as as Shean mentioned, if you over provision everything, you've got services that are idling, that aren't really doing anything. And if you are running traditional virtual machines, especially if you're in an Azure or an AWS, you're still paying for those. And sure, you can still shut them down, but there's still storage on the back end, and then you have to wait for them to boot up. So for a lot of our customers that are really adopting the cloud, that scalability becomes not just a user experience discussion and sort of multiplier, but also financial operations, FinOps, whatever you want to call it, to more efficiently have costing around that environment. So I know we're seeing quite a bit of that. So I wanted to call that out because I'm assuming that a lot of people watching this webinar are at least thinking about moving to the cloud or even already there.
Yeah, perfect call out, Tom. Thanks.
Back to you, Shean.
Yeah, so let's review and like summarize these differences here between VMs and containers. And for the architecture, A virtual machine is running that complete copy of the operating system on top of a hypervisor. So again, each VM might use gigabytes of memory just for the OS, even before your application starts. While containers, on the other hand, share the host OS kernel, and they package those application and dependencies together. So you're talking startup times that are much, measured in seconds rather than minutes. From an operational standpoint, the differences are just as significant. So containers will give you that higher workload density per host, being able to run dozens, even hundreds of containers where you might fit only a few VMs. So they're ideal for microservices architectures and work naturally with like the CI/CD pipelines that we're seeing now for faster scaling and deployment. Now, all that being said, that doesn't mean VMs are going away. Virtual machines still have their place, especially for things like monolithic applications or workloads that really need that hardware level isolation. And then also like legacy systems that can't easily be containerized, you're still going to be keeping those in, a VM environment. And also that stronger security boundary that VMs do provide through hardware level isolation, those are going to be important for certain like compliance and security driven applications where the requirements for that are much higher. The reality is like most organizations are going to end up running both. So it's about choosing that right tool for each workload. And, that's the exact kind of assessment we're going to talk about later in the session.
So with that, let's talk a little bit about the individual capabilities of containers and when it may make sense to run single containers versus multiple containers. So there are a lot of instances where running a single container does make a lot of sense. Usually for a lot of our customers, they're looking at tools like Docker to do this. So Docker works really well as a containerized platform just because it's a unified development and runtime experience, even though it does obviously use a CRI or container runtime interface on the back end. But for a lot of our customers that are running, lightweight applications, they just need an individual process to run every now and then. Local development. Shean mentioned isolation. Having individual containers for those specific isolated processes makes it so that running that in an individual or a singular container makes a lot of sense. Especially for those smaller applications and things like that. Docker also runs very quickly. So Shean mentioned several times, and we'll probably be hammering on this a lot during this webinar, is that containers are meant to start up in seconds. Everything from pulling from the registry to initializing the container to having it start up to just actually serving traffic. That's meant to happen in seconds, or at the worst case, usually minutes. I don't know, what everybody here's experience is, but in mine, running virtual machines or requesting new virtual machines from an infrastructure team isn't just hours. It can be days. Sometimes it can be even weeks. I've had customers that literally take 6 weeks to implement new virtual machines as they get requested. That's because of integrated security tooling. It's a lot of processes and review and things like that go into actually getting that deployment done. These containers, especially as you have your host set up to run them, essentially bring that down into that seconds or minutes. That, hey, I'm a developer, I've made a change, I've added a new layer, whatever that is, I'm going to go ahead and push that to the registry, or I'm just going to run it locally and see what it looks like and make sure it does work. And then you could start going into a more production level deployment. And that's really easy to do with solutions like Docker, and when you're running just individual containers. Maybe I've got a MySQL container, maybe I've got a SQL Server container, maybe I've got a web application container. Those all can run individually, even though they do need to interact with other services. But from a development perspective, they do work relatively well. The one big downside that we see from a lot of our customers as they're running those individual containers is a limited capability of scaling. So now I've got a single container running on a single host, and it's got a single process. So now if we do have some of those traffic spikes, it becomes a little bit more manual if I'm just running that single container to scale it out, to put it behind a load balancer, to ensure that it can support those traffic spikes as the applications are scaling up and down. So once again, while these single containers do tend to be pretty good for development for isolated, very low level services, it's not quite the end all be all, especially as we start talking about running these workloads at scale and in production. So with that, the main solution that we see for running multiple containers together is an orchestration platform like Kubernetes. So Kubernetes itself is, once again, not always going to be the best. We'll talk a little bit about what this looks like later, because it does certainly add that level of complexity to the environment. The important thing to understand is that Kubernetes itself is split out into two major components. You have your control nodes and you have your worker nodes. So on the control nodes themselves, these are meant to run your entire Kubernetes cluster, and then your workloads are meant to run, your worker nodes are meant to run your applications. Kubernetes uses a solution called pods, which we'll get into here in just a second. But from a control node perspective, there are a lot of solutions that go into that. So things like the controller manager, which is all about managing the cluster and making sure that it's in the desired state. If something does not match, the controller manager will actually reach out to the cluster and make it, match that state, whether it is deploying additional pods or making overall updates to the cluster itself. There is a REST-based API server that runs and listens for new pods to be deployed. That's what you deploy to if you're, running kubeadmin or kubectl, or you're deploying Helm charts or things like that. That API server is that individual deployment point that listens for everything and is what you're talking to as you're running your clusters. When you initiate new pods, when you make changes, when you make updates, whatever that is, all those get stored in an etcd store. So that's really just a key value store that is meant for running the entire cluster state and the entire cluster configuration. That etcd store is the brain. It is the memory of that entire cluster. If you are running Kubernetes and you're not backing up etcd in some way, shape, or form, you are going to be in for a bad time if something ever happens to it. Because if that store ever gets corrupted, you're essentially out of luck and you have to redeploy everything. Now, the nice thing about containers is that it does become relatively easy to redeploy. That's the entire point behind portability and the scalability of containers, but it's still a pain. You don't want to have to go through it. So make sure you're backing up all of your store components, primarily etcd, as you're running your Kubernetes clusters. And then finally, the major component we'll talk about from a control node perspective is the pod scheduler. So once again, you submit a new deployment into your API server. The pod scheduler is actually going to analyze that deployment. It's going to find the right nodes that either have the right capabilities or that have the lowest pressure on them right now, and it's going to go ahead and schedule those pods to run. And it's going to look at things like how many replicas you need and what that horizontal scaling looks like as well. So all that to say that Kubernetes is the mechanism that we do generally see when we are running multiple container environments. There are other orchestration tools out there. We're not going to be talking about them today because Kubernetes really has become sort of that standard for all of our customers and that overall container orchestration platform. So in addition, as I mentioned, to those control nodes, we also have our worker nodes. The main components that we're going to see on those worker nodes. So number one is going to be kubelet. So that is essentially the integration point behind the worker nodes into the control plane. So that's going to, have the worker nodes check in with the control plane. It's going to report health. It's going to look for new requests from the API server. It's going to be responsible for talking to any sort of container registry to pull images and to start pods. It's going to report that state back to the API server, so the API server can then report it back to you or whatever the front-end monitoring platform is. Kubelet itself is the overall container worker that interacts between the API server and what's called the CRI, or the container runtime. That container runtime is something like containerd. That's going to actually run the containers. That's the interaction between kubelet and the underlying operating system, the underlying capabilities and services, as Shean was mentioning earlier, that the operating system is then presenting through that container runtime. That runtime is also going to provide isolation between the processes. So once again, if I've got three containers over here that are running in individual processes, and they shouldn't be able to talk to each other, or they just need to be isolated from a security, from a management perspective. That container runtime is the mechanism by which they do get separated. And as I mentioned earlier, that is essentially the interaction between Kubernetes as an orchestration platform and the underlying host operating system. Once again, whether that's a bare metal host or whether that's even a virtual machine. Now, none of this stuff actually works without networking, because networking is what makes everything go around, and that's where we get the kube proxy. So all networking is handled by the Kubernetes proxy. Routes, IP addressing, service availability, all those things are enabled by that proxy service. If it's down, you really have no networking. It's also how you can have pods talk to each other. So if I have a process pod and then I've got a backend database pod, if I've got ingress controllers that are responsible for allowing everything to actually talk to these services, that's where kube proxy comes in. That allows for traffic from outside the cluster to come into the cluster. It allows for the intra-cluster conversations and network traffic, and even inter-cluster and inter-pod networking. So between multiple clusters and between multiple pods. So as we talk about the individual worker nodes, these are the three primary components. There are certainly more things that go into running a worker node, but as we have these sort of discussions, this is where we see most of those workloads and most of those capabilities coming in. And these are the main components, in my opinion, and I think most people's opinions on how we can actually run those workers. Now, onto those worker nodes, we start to talk about how do we do an actual deployment. So when I need multiple pods to be stood up or multiple containers, what does that actually look like? And what are some of the constructs or objects that Kubernetes makes available to actually allow these applications to execute? The number one thing that we've made a lot of references to already, and we'll probably make a few more as a part of this webinar, are pods. Pods are the smallest deployable unit within Kubernetes. These pods will consist of one or more containers that then get deployed as an individual logical unit. So for example, I mentioned this a couple times before, if I have a MySQL pod that just has a MySQL container defined within it, then that becomes that individual pod. That becomes a single logical construct. There could be 500 replicas of that MySQL server pod in the container, but it's still managed as a single logical unit. I could have multiple containers be a part of the same pod as well, and they're all going to scale together as well. And a lot of that is going to be handled by what are called deployments. So deployments allow me to do idempotent deployments, implementations, not to use the word in the definition. If I need to update to deploy a new version of a container, if I need to roll it back because the new version did not work properly, if I need to auto scale, if I need to auto heal, a lot of those capabilities are going to be managed and defined in those deployments themselves. So those deployments become the primary mechanism by which we actually get pods to deploy into the cluster. You don't have to use deployments. There are other ways to do it, obviously, but from an overall management capability, we tend to see deployments be that primary way to do it. If I need to have separation between my pods for different, teams, so my finance team versus my marketing team versus my IT staff, whatever, maybe I want separation between my environments. So software-defined lifecycle environments like development, testing, production, et cetera. I can create these namespaces to be able to make that work. Sometimes there are mechanisms, or there are times that maybe you want different clusters altogether than namespaces. Once again, that's something that we would discuss during an assessment to see what that architecture and what that infrastructure looks like. But if you do need some logical separation from your pods or between your pods, then namespaces are primarily the mechanism by which you can do so. As you expose services, or as you expose these pods to the outside world, there are two primary ways to do it. So number one is going to be services. So services are a way that we can give a single IP address to a pod, even though it could be deployed through multiple multiple nodes within the cluster, unified DNS, integration with external services, external capabilities or external solutions. Services are essentially the layer 4. That's the unified networking. That's how we can expose these pods to the outside world. If I need to allow services to, or if I need to allow users or external applications into the cluster to talk to pods over layer 7, so it's going to be for primarily for HTTP, HTTPS, that's where an ingress comes in, or an ingress controller. The biggest one that we're seeing, or the primary one that we're seeing in the environment at the time of this webinar, is Nginx. That is actually being deprecated. So the Nginx ingress controller is being deprecated from Kubernetes. So we're seeing a lot of our customers shift over into gateway controllers. If you aren't familiar with this, or you are running Nginx in your Kubernetes environments, reach out to us and let's talk about what that looks like in terms of deprecation. Once again, these pods are meant to be non-persistent. So how do we get persistent storage? This comes in the mechanism of PVs, or persistent volumes. This is how we can provide storage to deployed pods. I mean, we can have that storage be shared by multiple pods that are all making the same writes. Persistent volumes can be presented off of a lot of different storage backends. A lot of that's going to depend on whether you're running on premises, whether you're running in Azure, or whether you're running in AWS. All those have different mechanisms of provisioning and maintaining these persistent volumes. But those are the ways that we generally are going to support having that backend storage for the pods. Now, this is not an exhaustive list of Kubernetes objects. There are things like, secrets and configuration maps and stuff like that we're not going to get into as a part of this. But once again, these are the primary constructs that we see as we're talking to our customers and we're designing these applications. So all that being said, I've made a couple different references in the fact that, Kubernetes isn't always the right solution. Sometimes it does make sense to run individual containers. If you have simple applications that need full isolation, that don't necessarily need to talk to other services, maybe they're running background processes and just making outbound calls. Maybe you're just doing development. Maybe you want to minimize complexity in the environment. Running individual containers in Docker or in Containerd still may make sense. This is sort of what Shean was referring to earlier as well, is that there's a good chance that you're going to be running containers and virtual machines side by side for the foreseeable future. It also means there's a good chance that you're going to be running, individual containers and orchestrated containers alongside each other as well. That being said, if you do need fault tolerance, if you do need horizontal or even vertical scaling, if you need multiple deployments or automated deployments, if you have multi-container applications, that's where we start to see Kubernetes really start to shine. It's where we really start to see those orchestration platforms be a major benefit to the organization and justify the additional overhead and the additional management that comes with having your control nodes and having, sort of that back end and those additional components. That being said, I would be remiss if we didn't talk about cloud platforms. Azure and Elastic Kubernetes services across Microsoft and Amazon's control planes and cloud platforms drastically reduce the overhead that is required to running Kubernetes clusters, because it's essentially allowing those platforms to run those control nodes for you and to do all of the self-healing on the control side for you without you having to manage them on bare metal or individual virtual machines on premises. So as we're starting to talk about modernization, especially as our customers are moving into the cloud, having the understanding of EKS and AKS and the benefits they provide can also ensure that you're migrating to the cloud most efficiently. Before we move on to the next topic, Shean, turn it back over to you for a second. If you have anything you wanted to add on Kubernetes orchestration, single versus multiple containers, before we start talking about assessments.
No, I think you covered all of the high points there. So thanks, Tom.
Perfect. So with that being said, let's talk about assessments. The biggest question we get a lot of times from our customers is, why should we start with an assessment? If we already know our applications, we just want to start moving, we want to start churning and burning and coding and getting this thing modernized. However, and I'm sure Shean will agree with me, and we'll talk about this again a little bit later, is that assessments are the best place to start in your environment, because not every application is going to be a candidate for modernization. If you have off-the-shelf applications that you've purchased instead of from what you've built yourself, if you have applications that are slated for deprecation, maybe you've got overly complex or business critical applications that aren't good candidates from the beginning, they may not be a good modernization candidate. They may not be good for containerization. Going through that assessment as that first piece is exceedingly important. The other thing to keep in mind is as you're running through the assessment, the things you should be looking at overall. So number one is that current architecture. Do you already have a modular application? Is it a giant monolith that needs to be broken up, which Sean's going to talk about here in just a little bit? You know, that's going to change your timing. It's going to change your criticality. It's going to change, where in your modernization journey you put that given application. What runtimes are in use within the environment? How do they containerize? Do they containerize really well? Do you need to look at alternatives? So things like if you're running, full versions of .NET, do you need to start evaluating .NET Core or some of the other capabilities and containerize sort of layers that you can add in? What dependencies exist in the environment? We'll talk a little bit about dependencies here in the next couple slides as well. But are there other things that will prevent you from modernizing because those dependencies don't operate properly with a containerized workload as that middle tier? Also, as you are moving into the cloud, integrate these assessments into your cloud migration journey. As you're having these discussions, as you're evaluating cloud platforms, as you're evaluating what should move or what shouldn't move or what should be deprecated or what's going to move as a rehost or a forklift migration, fit in a modernization assessment because it does become a core part of that modernization journey. So that being said, where do we start? What does this look like? Where we generally recommend is start broad and then go deep. So number one, catalog your entire portfolio. Most of the customers that I talk to and most of the clients that we have these discussions with don't even have an application portfolio. They don't have an application catalog. They just know they have a bunch of stuff out there that people have requested over the years. They don't know what's in use. They don't know what everything is running. They don't know how many applications are running on a given virtual machine, for example. So look at your entire portfolio, build an application catalog, start to look at the overall set of applications you have in the environment, and then start to categorize them. Look at criticality, look at complexity. Once again, looking at monolith versus microservices. Look at the tolerance for change. Do your application development teams have the ability to make changes? Are they underwater? Are they overly busy? Can the business tolerate changes to this application? If you're in the middle of reconciliation and closing out your end of year, you probably don't want to start modernizing your finance applications. That's a good way to make everybody pretty irritated. Once you have that portfolio and that catalog, identify those quick wins. Identify the easy modernization targets that you can start showing value right away. And that also starts to get into that next level deep. So dive into your individual applications. Start with those quick wins. You want to show immediate value. You want to make sure that, as you have this initiative, that your teams are able to showcase the capabilities of and benefits of modernizing these applications into containers. Determine how it runs. Is it a web service that needs that ingress in Kubernetes like I was talking about before? Is it just an isolated service that's maybe making outbound calls? See how it runs and sort of map that into containerization capabilities and to what those containers are going to look like longer term. The final major piece from those individual apps is that application stateful already, or is it stateless? So if you have stateful applications, we'll talk about this here in just a second, you may have to implement additional capabilities to maintain that state outside of the containers. Because keep in mind, stateless containers are the norm, and containers themselves are generally meant to be stateless. That's how we can scale them out. That's how we can deploy new ones. That's how we can make sure that they can be deployed the same way across multiple different environments. The last major piece is going to be dependencies. Look at external systems, whether it's databases, whether it's identity, things like Active Directory or OIDC, integration with Entra, for example. This could be DNS. It could be integration into your networking stack. All of these things start to be really important. The other piece that you need to keep in mind is things like secrets. How are we backing up persistent volumes? What logging am I using today, and how does that change? Am I going to move to something like a Prometheus? Do I need to implement a solution like Datadog? Where am I storing my secrets? Are they going into something like an Azure Key Vault when previously that wasn't a thing? All these dependencies start to be really important, and they really help sort of shape what your container strategy is going to look like, what your orchestration strategy is going to look like, and how you can secure and monitor and maintain that environment. Now, when we're talking about modernization, there are some tools out there. There are far more than just these two, but we did want to highlight them. So number one is going to be Azure Migrate, and number two is going to be AWS's App to Container, or A to C. Both of these are really good for analyzing applications. They can do dependency mapping for you. They can look at the underlying framework, the operating system. They can give you an idea on whether your applications are even suitable to be containerized. Maybe they have dependencies that preclude them from being modernized. So these solutions and these tools can actually come in and give you that overall review and insight into what it would take to bring these containers specifically into Azure or into AWS as a cloud hosting platform. Once again, whether that's running on a containerized PaaS service or whether that's running on something like an AKS or an EKS. I know we're talking about primarily assessment here, but both of them also have some capabilities in being able to do that modernization for you, depending on what the underlying technology is and depending on the suitability of those workloads and those containers to be modernized. So as you're moving into the cloud, as you're evaluating into getting into these more modernized workloads, don't lose sight of using some of these first-party tools like Migrate and like App to Container to perform those assessments for you. Now, the other primary topic of discussion around assessment that I want to get into before I turn it back over to Shean to talk about some additional modernization tips are some pitfalls. And number one, which I've referred to already, is state management. Whether it's access to a database, whether it's access to file shares, whether it's individual user sessions, keeping state in mind is very important because, once again, containers are meant to be stateless. There are situations where a user can be routed between multiple different containers on multiple different hosts. If you don't have some sort of centralized state management for that, you can essentially have poor user experience. You can have connections to databases that keep dropping and being recreated, which can exhaust connection pools, things like that. So there may be instances where you need to implement a solution like Redis or some sort of external state management to essentially ensure that that state is being routed properly, it's being stored properly, things like that. Number two, as we start to talk about containerization, is scaling. Some applications, and in my experience, even a lot of applications do not scale horizontally unless you have that sort of capability built into it. So horizontal scaling, by the way, is essentially just adding additional pods into your deployment. So if I can go from 3 to 20 back to 5, for example, that's that the spikes that Shean was talking about earlier. But unless you have your containers and your applications configured to support that properly, horizontal scaling may not work for you. You may need to go in what's called vertical pod auto scaling, or VPAs, which are generally a custom resource within Kubernetes to be able to scale a container up instead of scaling a container out. Not all Kubernetes clusters and not all custom resources are going to be configured properly for vertical pod auto scaling. So you need to make sure you've got that set up properly. Also, VPAs can drastically reduce the availability of node resources if you don't have them set up properly. To say, okay, well, if this container can scale from 256 meg of RAM all the way out to 256 gig, that could be majorly problematic. You want to make sure you've got those constraints set up within the environment. Security is another huge one. So making sure you're doing some sort of vulnerability scanning, not just for individual layers, but how the layers in your containers interact with each other. Making sure you've got solutions like Calico or other CNIs or container network interfaces that allow you to do pod isolation while still allowing proper integration and proper connectivity between your pods. Making sure you're doing secure secret storage. Don't just store your secrets in config maps. Don't store them as environment variables. Make sure that you're injecting those at runtime. Make sure that you are storing them in, like I said before, like an Azure Key Vault, for example, to make sure that you do have that sort of centralized and secure storage for connection strings, for other secrets, for API keys, and things like that. And then last, but very certainly not least, is choose the right platform. As mentioned earlier, Kubernetes may not be the right platform for you. You may need to do individual containers, or you may want to do individual containers and not have that additional overhead. Don't think that just because you're running a Kubernetes cluster that everything has to go into it. You know, to hammer everything is a nail, something we hear a lot in consulting. And it certainly rings true as we start talking about what that target environment looks like. Also, don't forget about other cloud services. On Azure, for example, we've got Azure Kubernetes Service, we've got container services, we've got platform services. If you want to run, you know, SQL Platform as a service, you want to run MySQL as a service. You know, there are situations where you may want to run those as pods or containers or just straight PaaS services on the cloud platform. So if you're not sure what the right target should be, that's also where people like Shean and myself and our engineering teams can come in and help make those recommendations on where that final state should be as you are implementing and modernizing these services. So with that, I'm going to turn it back over to Shean to talk a little bit about additional modernization tips and what we're seeing as with our clients as we're modernizing applications. So Shean, it is back over to you.
Thanks, Tom. Yeah, the biggest mistake we see is companies that just want to take that monolithic application and just wrap it in a Docker container and call it done. So in that sense, you haven't really modernized, you've just repackaged those same problems. So what we want to be able to do instead is look for natural service boundaries in your code base and extract all of those components that could potentially be scaled independently. So for example, like imagine you've got a legacy e-commerce application that's been running as a single monolith for years. Product catalog, inventory, ordering, payments, shipping, user accounts, all of that in one essential code base, deployed together, scaling together, even though those individual functions might behave very differently. So we've already talked about natural service boundaries. We're looking for parts of the system that already have clear responsibility, their own data, different scaling needs. So in this example, that product catalog is a great first boundary. It's mostly read heavy, changes infrequently, and doesn't need to scale at the same rate as like say your checkout service. So that makes an excellent candidate to extract out into its own containerized service. Another common boundary might be, in this example, order processing. Orders will typically follow that discrete life cycle: created, paid, fulfilled, shipped, and then they often integrate with other systems like payment gateways and ERPs. So by pulling out that order processing into its own service, you can scale it independently during peak demand without having to scale the entire application. The important thing here is that we're not chopping up the application arbitrarily. You're essentially following those existing business capabilities and data ownership. Each extracted service has that clear purpose, its own data, its own well-defined set of APIs. And then over time, as more services are extracted, that legacy system shrinks naturally rather than having to be rewritten all at once. Second big thing, standardize your base images. Like every team building their own base image from scratch is a recipe for inconsistency and big time security gaps. So you want to centralize that and maintain that curated and improved set of base images. Makes patching easier and it makes build times faster, and therefore you're going to see better user experiences and more consistent user experiences. Next, thirdly, extract that configuration from the container itself. If you're trying to bake in connection strings and feature flags and environment specific settings into your container images, you're fixing the operation of that container to that specific environment. So you want to be able to use environment variables and config maps or a secrets manager so that you can make sure that that single image can run identically across dev, stage, and production. And you put those specific configurations by injecting them in at runtime. Fourth, you definitely need to implement health checks from the start. So things like liveness probes to tell your orchestrator when a container is stuck and needs to be restarted, readiness probes that will tell your load balancer when a container is actually ready to handle traffic. Without these, you end up routing requests to containers that aren't ready, they're still initializing, or maybe they failed even. So that's really important. And it's also important to do all of this up front, where it's far more easy than trying to like retrofit that into your environment later. And finally, as Tom mentioned earlier, plan deliberately for stateful workloads. Not everything is that stateless API. So databases, message queues, file processing services all need that persistent storage. And you can use things like managed database services or Kubernetes operators to handle the replication and that failover. Like the key principle here is you want to separate all of that compute from your storage here so your containers stay portable. Did I miss anything on that, Tom?
No, I mean, I guess I'll go back to that. I think you really covered all of it, and kind of reiterated some of the things that we've been talking about during this webinar. I think number one, decomposing before you containerize, that's huge. The easiest way to sort of fail this modernization journey is by trying to treat containers like they're VMs. It's the same thing when we went through virtualization, however many decades ago, is trying to treat virtual machines like they're physical servers. There are enough differences that you need to make those distinctions and understand sort of the best practices in running those environments. So
Yep.
I definitely want to call that one out. And self-serving, it's also an area where we can help as an organization if you're not quite sure where to start. But we'll get into that here in a little bit.
So how do you actually approach and structure your modernization efforts? We believe in considering breaking these down into those three phases. So assess, transform, and optimize. Tom went into a lot of detail on the assessment phase, so I'm going to move on here and talk more about transformation. That's where that real work happens. And in this case, like I'm going to use an example here, that strangler fig pattern. If you haven't heard of this, it's named after that tropical vine that gradually wraps itself around a tree. And so this pattern is essentially allowing you to migrate incrementally rather than having to do that big bang cutover. You can modernize by gradually replacing those systems component by component. So you can start by putting in an API gateway or reverse proxy in front of your legacy system, and then build new features as containerized microservices. So by routing the specific traffic to the new services, while that legacy app continues to handle everything else. And so if you keep doing this over time, you can extract more and more functionality until that legacy usage just shrinks to nothing or a very small manageable core. And that key insight here is you're not actually disrupting production while you do this. Users don't even know the migration is happening. And finally, let's move on to optimize. We see customers skip this phase a lot of times, but really this is where that real cost savings and performance gains live. Once your workloads are containerized and running, they need to be right-sized. And so set the CPU and memory requests based on actual usage, not just guessing. So whatever you start with when you're setting all of this up, it may not be where you land eventually. So you want to be able to implement features to be able to move that around and tag things for cost allocation so you can trace back your spend, things like that. And the key really though is don't just do this once. You have to make the ongoing discipline of reviewing your resource utilization. So things like doing it monthly so that you can regularly tune those scaling policies. It's really a good way to make sure that that initial cost savings isn't just static and can be ongoing because you can continue to improve your performance and cost savings, keeping your leadership and your users happy, which is really the key point there. So let's zoom back out for a second. We started like looking at the old way of doing things, bare metal, VMs, all of that overhead, and talked about why that's not optimal anymore. Then we got into things like containers, what they are, why they've taken off, faster deployments, better resource utilization, scaling automatically. We looked at the differences between running through single containers and going full orchestration with Kubernetes. And we just talked about a realistic game plan for getting there, how we assess, how we transform incrementally so nothing blows up, and then being able to continue to optimize and squeeze value over time. So these kinds of things, like, they're not theoretical anymore. Our customers are doing this all the time and seeing real results. So with all that context, let's talk about what our team can do to help you get there.
Yeah, absolutely. And as Shean has mentioned, and as you can see here on this slide, our teams are ready and available to help. One of the big areas that we've seen a lot of benefit in is what we call our springboard, which is essentially like a sprint zero. So what this is we can actually come in and work with your application teams, work with your application owners, work with your business owners, and start to identify applications that can be modernized. We can actually start to build out backlogs to show what that modernization effort looks like. We can help you identify those low-hanging fruit and those quick wins and things along those lines. We have the expertise and we have the team that's done this for dozens, if not hundreds of our customers, to be able to do this analysis, make those recommendations, and start you off on the right foot as you get into that cloud modernization or the application modernization journey. As we get into the journey itself, we also have teams that are well versed to do application development. We can have them either operate as an individual team within your organization. We can actually embed those people with your development teams. And so we can essentially have your teams learn from them. We can essentially teach how to operate in this new model of containerization and modernized workloads. At the end of the day, help you ship real containerized and modular applications. So we have the teams all around the world to be able to support that and to support your engineers and to support your developers as you run through this journey. If you're not quite sure what you want to move or you want to do an assessment that also encompasses potentially rehost or even retiring applications, we can also help do a cloud migration readiness assessment. So we can come in and run tooling from Azure or from AWS to help give you that insight into the environment. This can be coupled with that springboard. So once we find the applications, we can help you with that sprint zero. This can also be coupled with an actual rehost migration. We have the teams that have the expertise for doing a lift and shift versus just doing modernization, or once again, a combination of the two. As Shean mentioned earlier, and I'll call back to that again, odds are you as an organization will be running both for a relatively protracted amount of time, just because modernization does take time and effort. And then finally, if you don't have a cloud presence today, and you're planning on migrating, you're not quite sure what it looks like in terms of having a secure front end, all the monitoring, all the security tooling, and all the things that we've referenced a handful of times during this webinar, reach out to us and we're happy to talk landing zones with you. As you move into Azure, as you move into AWS, how do we build that secure foundation to make sure that as you're migrating, as you're modernizing, as you're deploying these services, that it's all standardized, it's all secured, and you have proper visibility into things like cost management, tagging, and some of the things that Shean mentioned as part of that optimize phase. So how do you operationalize that environment? How do you run it longer term? This is just a subset of the things that we can help with as we're talking about modernization and getting into more cloud native services. Shean, anything else to add to this slide before we wrap up?
Yeah, I mean, one thing we didn't mention here is AI, and we do talk about that and with most of our customers. So, that's another piece that fits into this specifically as you're talking about modernizing applications. Are you looking at being able to leverage your information, your data for agentic AI purposes? And so that's another area where modernization really sees gains for customers these days.
Yeah, I guess we're failing our marketing team right here because we didn't mention those two favorite letters for everybody. But yeah, and one thing to keep in mind as well is that a lot of AI models are meant to run in containers. So as you're building out your infrastructure to support your homegrown and internal applications, that can also enable you to start deploying these AI models in more of a sovereign AI capability if you have your own on-premises hardware, or obviously in the cloud, depending on what cloud platform you're running. So perfect. So with that, If you are evaluating application modernization, if you want to have future conversations about containerization or cloud in general or any other topic, you want to get a hold of myself or Sean or any of our other experts on our engineering teams, reach out. If you have an account executive with Netrix today, you can reach out to them. If you don't, please send us a note at info@netrixglobal.com, and we'll work on getting something scheduled and a meeting to talk about some of these topics. But with that, my name has been Tom Lilly, also with Shean McManus. Thank you all for joining this webinar, and I hope you got something out of it and hope to talk to you soon. Thanks, everyone.
Thanks, everyone.